Hello, everyone. It's time for Catalog and Cocktails presented by Data.World. It's your honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, joined by Juan Sequeda. Hey, Juan.
Tim, how are you doing? It is always a pleasure to take a break during the week, end of your day, or wherever you are, and chat about data. And today, I love it when we have a guest that you meet somebody in person and you just hit it off and you're like, oh, wow, like we need to have you on the podcast. And that is the case today with Hugo Bowne-Anderson, who's an independent data and AI scientist, consultant, educator. We met at MLOps Austin last year, and we were just, I was randomly invited last minute because of some stuff on a panel, and we just hit it off so great. Hugo, how are you doing?
I'm very well, and it was great to meet you last year. As we just discussed, I've been following Data.World since the early days, so really fun to come and chat with you all. And it was MLOps World, of course, necessarily rebranded as Gen AI Summit because that's where we are in the hype cycle with MLOps and generative AI. But hands down, one of the best conferences I get to go to, and the work Dave Schalbach and the team do, so wonderful. And getting to meet people like you, and then, you know, making friends and doing more great work together. So shout out to Dave and the work there.
Yeah, likewise. I think what was really cool for me was it was an opportunity to get out of my own bubble because I don't go to the MLOps or some conferences. So it was great and lead to meeting folks like you. So awesome. Hey, so let's kick off. Tell and toast. What are we drinking and what are you toasting for?
Yo, so I'm drinking. So it's 7:30 in the morning here. So as we joked before, even though I'm Australian, I felt like it's still a bit too early. So I'm having a damn fine cup of coffee, and I'm toasting to something pretty geeky. I've got several people I'm working with building LLM-powered applications, and I'm helping them develop testing before rolling it out to users by using LLMs to generate synthetic data. So generating user queries in order to develop a rapid data flywheel for LLM testing pre-launch.
All right. And I think one of the things I do want to toast for is that you also have a course that's coming out or started or is starting.
Yeah. It actually starts on April 7, which is next week now. So probably a few days after this episode goes out. And it's a course on all of these things. So it's building LLM-powered applications for data scientists and software engineers. It's part of the work I do now. I've been classically...
Wait a minute. We lost your voice, your audio for a second. All right. We're going to keep it going because this is the honest no BS right here. So
exactly.
You're back. Okay, there we go. So it happens sometimes.
Yeah, and I'll just start again. Yeah, absolutely right. It's April 1st here in Australia. No joke. It is April Fool's. The course starts next week, and it's building LLM-powered applications for data scientists, MLEs, machine learning engineers, software engineers. We may get to this, but one of the things I'm really excited about at the moment is I've classically worked with and taught a lot of data scientists, MLEs, AI engineers, and now I think with the technology around, there's a huge opening for software engineers, UX, PMs to come in and really contribute hard to building ML and AI-powered software. And this course, I mean, we do all like the hottest new frameworks and MCP, of course, and agentic stuff, but it's really, a lot of these things will come and go. So we're really trying to focus on first principles in this course and ground in the principles you need. And some things differ, but in all honesty, if you've been building data-powered products and ML-powered products, you already know the first principles, and it's about figuring out how to apply them to the new generative AI stochastic world.
I love that we're going to dive into this because this is the principles is what's so important.
Yeah, that's the part that's going to last a little longer. Right? This technology is changing so fast, but the principles are the key.
Absolutely.
Tim, what are you drinking and toasting for today?
I am drinking some Hendrick's Grand Cabré gin, and I am there's some blood orange in it, and there's some cranberry in it. So just kind of a clean drink. Oh yeah, a little bit of soda as well. So and cheers to writing and getting the content out there. I'm really excited about your course, Hugo. Can't wait to check it out.
Awesome.
And I'm drinking just a rum soda. I actually have I had a bottle right there of Flor de Caña rum, and then I have one of my favorite Austin sparkling waters, Waterloo, of lemon and lime. So this is a good combination. So nice and refreshing for you start to get that. I think it's the heat is starting to come to Austin very early. So cheers for getting content out and for getting courses and start and teaching and helping other people to learn. So all right, so we have our warm-up question, which is because we're going to be talking about how to get out of proof of concept, kind of purgatory and so forth. What is something that you really struggle to, or whatever, you never get out of a proof of concept personally?
That's a great question. I mean, you mean with respect to software and machine learning, or
just actually in your day-to-day life? That's what I was thinking. I was kind
When you're
of
experimenting with something?
Well, I mean, I get round to it in the end, but doing the dishes, dude, that especially because at the moment I do work from home, they pile up quickly, and that, like, the proof of concept of doing the dishes is easy, totally easy, but the actual, getting that, SHIT, pardon my language, in production, super tough sometimes.
That's a good one. I actually think I have a somewhat of a process down for it, but I don't love doing it. But
well, you need the process, right? That's
yeah,
That's the key, and you got to make it into just a rote behavior. Like dishes is easy for me because I did it for 4 years in high school. That was my high school job. So for me, I like my eyes are closed.
My challenge also is previous place I lived in had a dishwasher. Don't have a dishwasher anymore. So like a physical dishwasher, not a person, or like in the Flintstones where they have like some dinosaur that does it for you.
All right, well, let's kick it off because there's so much to talk about here. All right, honest, no BS. How can everyone build with AI today?
As I said before, I think this is just an amazing time for so many people to be brought into the fold of building software, and even if it isn't building something necessarily for production use case, going out to millions of users. And I actually think the first way to do it is to start having conversations about it, both with your team, both with friends, family, colleagues, whatever it is, and with large language models also. So someone who's a bit technical, told me they wanted to learn more about the command line and where they should go to learn it. I told them a number of different places to learn it, including courses I've taught. But I also said, go cursor agent mode. This was the other day when Gemini 2.5 came out. Go and tell Gemini 2.5 exactly who you are and tell them to iterate on a course with you and build a command line course for you. And it build it out personally for them. And that this is such a wild time to be able to do that type of thing. But it involves an experimental mindset and curiosity. And I always think about, like you guys, I've worked in startup land for a long time. And, when you start a startup, you want to hire explorers, right? And have people who can, bush bash, jump in the river, set up camp, move on the next day. When you get to Series B, Series C, whatever it is, you want to start like getting settlers and people who build structures and like build a medicine tent and have a doctor and these types of things, right? But I think what the point I'm trying to make is that now I think nearly everyone in an organization, for the most part, needs to go back to exploration mode because we're in such a chaotic technological environment. That's all to say, the way to do it is to explore as much as possible and don't necessarily be afraid of technical things. I do think this is the first time as a civilization we've reached the Holy Grail in some ways. And I don't really mean that religiously. I mean it more in terms of Indiana Jones finding the Holy Grail, I think. But where we can communicate with computers in natural language. We've reached the abstraction layer where we can develop software using natural language. And I don't necessarily want to get in the vibe code versus no vibe code flame war, because clearly putting stuff in production that you don't understand is stupid. But I think that's an absolute red herring that I see on LinkedIn or TikTok for adults all the time now.
You stole my question. I was going to ask you. So vibe coding, good, bad?
Yeah. But for me to spin up an ephemeral JSON viewer for an LLM I've just built that only I will use, and I write a few tests around it, one of the best things possible. So anyone who's saying, vibe coders 100% suck, I mean, it's a straw man. It's not even wrong, actually, in the famous words of Powling. No one's, besides some idiots on social media, no one's claiming you can push something to production via vibe coding. Sorry, I derailed myself.
This is a good. I mean, one of my colleagues I work with, Dean Allman, we were talking the other day. He's like, the amount of productivity that you can go do with these LLMs, it sometimes is almost an infinite, because it's not like I could have done it before and I'm just not more efficient. It's like I would have never been able to do it, and now I'm able to do something that I was never able to go do before. And like that is that exploration. And I think that's the mindset that people should be having now. Is like, you thought you never could do this before, like actually go try it right now, and actually you can do it on your own, and in a judgment free zone too, right? Because I think that's the other thing that I'm seeing. A lot of people are like, oh, I'm afraid this is a stupid question. Like, well, look, if you don't feel comfortable asking this, fine, I get it, but here's this place you can go. You can ask all the questions in judgment free zone and learn. So
totally agree. And the one thing I will say is that you can't do this right now if you don't know how to program yourself. I want to make that very clear. Even knowing a bit of Python and a bit of command line can like supercharge you. I used to hate the term 10x anything, but I actually think that's more possible now than ever if you know the basics, right? The other thing is figuring out ways to superpower your workflow. So I actually got a Stream Deck recently. I don't know if you know these things. They're like they're essentially buttons and knobs that I can assign to macros on my keyboard. So I can now press a button that will open ChatGPT, turn my microphone on, give me a prompt template, well, like whatever it is, right? But what I actually use it for, I use Super Whisper, which allows me to dictate to any app. So I open Cursor in agent mode, open Sonnet 3.7 Max or Gemini 2.5, all with one button. With another button, I start dictating into it, telling it to build something. Then I press the same button and it starts executing. I've been building things for days, almost keyboard free through these types of conversations. Now, huge gotchas, like 3.7 Sonnet will write really verbose code, and it will like really make your code base sprawl, right? It will create files and subdirect. So you need to be really on top of that. So you need to understand how to build systems, right? But this is the amazing thing now. I get to not focus on figuring out whether I want PD, iLoc, or loc, or X like I was doing a decade ago, or trying to figure out how to turn a data frame into a NumPy array with one hot encoding because this other thing didn't work to feed into a scikit-learn pipeline. I get to orchestrate systems and not worry so much about the APIs because of the recycled intelligence of the AI systems. It's already there. Amazing time.
It's a really incredible time. And I know, like, for example, just at Datadog World, right, in terms of our own dog food, just like everybody getting their hands on, these services to help with generating code is letting people move faster. But to your point, like some of these things, you can create straw mans just incredibly fast. Like, hey, I need to wrap an API around this. Like, oh, that's such an easy rote task for AI to help you, finish in a day, right? So how do you, I feel like you mentioned you got to get started with a few things, right? You should know Python, you should know command line, you know enough about systems. Like, how do you approach learning to code in today's day and age when it is so easy? Is it one of those things where, I think about like when I went to school, right? And, when it's time to take the test, you close the book, you leave the laptop off to the side, no cheating. Like, it's time for you to take the test and show that you actually know the content, right? Are we going to have to get pretty good at that too, when it comes to learning new programming skills and things like that?
So you get good at memorization? Is that the question? Or
get good at putting Gen AI away and making sure that you can do it without it and then pick it up again? Or is that silly? It's all integrated now.
Well, I mean, you can ride a bicycle if you want to exercise and you don't want to pollute the environment so much. But if you're driving, 1,000 miles, I'd probably suggest using a car, right? So I think if there's a reason to not use Gen AI, I'd do it. But generally, now with at least building software, I don't know anyone who spends more time not using Gen AI than using Gen AI. And this is a really nascent technology, right? Also, look at some of the sadness around. Look what it immediately did to Stack Overflow in terms of their traffic and business model.
That's way down, right?
It's devastating. And I mean, one way to think about that is I personally don't want to live in a world where there's one model to rule them all. Clearly, that's not going to happen. 6 months after saying that, Sam Altman pivoted when he saw what was happening, right? But I would prefer a world in which, maybe even we have like decentralized models, maybe as public utilities that we can fine tune ourselves, these types of things. But just imagine if Stack Overflow could have its own LLM where we can go to their website and query it and get out results. Or like we're seeing a really wacky legal fight played out between OpenAI and New York Times because OpenAI clearly went behind a paywall and scraped data. I don't think that's a controversial statement. And I'd prefer to live in a world where the Times had its model, which we could query, even if it has an OpenAI backend, right? So having said all that, I don't want to look a gift horse in the mouth, and the ability for me with languages I know, so the general machine learning, AI, data science stack, like PyData plus with, you know, your scikit-learn, then XGBoost and PyTorch and all the LLM stuff on top of it. Most of this is in the training data. Of course, the joke is ChatGPT doesn't know the most recent, GPT 4.0 doesn't know the most recent API for itself, so totally messes it up all the time. Because for some reason, they don't ground any of these in their own documentation. Who knows why?
Oh, the irony.
Yeah. But if you don't know what you're doing, you can really get messed up. As I said, I'll spin up like JSON viewers for my LLM traces just to see conversations. Also to hand label it. I can spin up an HTML labeler really quickly. And that's fine. I make sure I test it for some of the important things. But if I then had to edit the JavaScript or something like that, I'd be lost. Or like if it spits out React code, then I would be lost. So it's real buyer beware times as well.
Yeah. No, this buyer beware, I think, is a good segue into, I think, the next topic we want to hit together, which is around how do you bring, I think there's two aspects here, and I'm curious if you have different answers for them or the same answer. How do you bring applications to production in this landscape of Gen AI? And I think one aspect is Gen AI helping you to create your applications. And I think we hit a little bit of that already, which is like, you need to understand what it is that you're doing and what you're working with, right? This you can't just like expect the AI to do everything for you, at least not yet, right? Bringing applications that Gen AI helped you write to production, so that's kind of one thing. And then the second thing is Gen AI applications, bringing them to production, right? So curious about your thoughts, and I know you've written and have a lot of thoughts kind of on this topic.
Yeah, so I'm hearing a distinction there is writing software that's powered by Gen AI itself, like having LLMs in the software, then writing software and you're using LLM assistants or agents to help you write it. Those are two different.
I see those two distinctions, right? Is that something you're seeing too?
Yeah, absolutely.
I think there's different ways of approaching it. So get curious about how are you approaching this and like turning this into stuff that is in production, that's going to be out there to use and provide value.
So the first thing I'll state is that I think we need a more nuanced definition of what production is. Like the gatekeepers of production are like production or not, and that's very far from the case. So I'll give a silly example, then I'll give a few other examples. A friend of mine vibe coded, and a colleague of mine vibe coded a chess tutor, TUTOR. In Australia we say tuner and tutor. A chess teacher app, which he then sent to 20 friends or something like that and helped them, had a few bugs, that type of stuff. Now, that isn't productionized like Google search, but in all honesty, I think it'd be an interesting conversation for someone to present that's not in production in some sense. I mean, he has real users. It isn't necessarily load balanced and that type of stuff. And in fact, my former colleagues who were at Netflix, they would roll out things internally, and this would be the first step to roll out something and get some feedback. Then increasingly, then you maybe do some vertical scaling, some horizontal scaling. Then you roll it out to a small subset of users. Get immediate feedback, especially with ML powered apps. You really want to look at like diagnose drift and these types of things early on. At that point, you probably introduce some versioning and that type of stuff, but maybe you don't have an experimentation framework where you can launch a challenger model. And then if it beats your champion model in production on certain metrics, you then upgrade it to champion. So all of these things are part of the productionization story, right? So that having been said, when it comes to incorporating large language models into software, and we can link to an essay that I published earlier this week on O'Reilly Radar, but this idea of proof of concept purgatory really comes down to the fact that I feel like this type of software is perfect for like the attention-driven social media, ADHD, like space we all live and work in constantly, right? And that isn't to cast shade upon anyone, right? But when you build an AI-powered app, it's like this flashy demo, right? And you get excited straight away. Then you're like, oh, wait, there are some hallucinations. I'm getting less excited. Then it's like, oh, how do I integrate this into my pre-existing software stack? Ugh. Oh, how do I monitor it? Oh, and so on. So excitement decreases as a function of time. And I oppose this to traditional software development, which is anything but exciting at the start, right? You have a hello world, then perhaps you add some basic functionality, then you refactor, build out some tests, then maybe you serve to some users and load balance, that type of stuff. And over time, it gets more and more exciting. Whereas LLM-powered stuff is super exciting at the start. You get these flashy demos, but over time, and far more rapidly over time, it gets less and less exciting. And the way I think about how we can make and so I'm now talking about, this is the course I teach, right? And what I do a lot of consulting on, how to build robust and reliable LLM-powered software. So what I mean by that is stuff that works like software. You have a sense of what it's going to do given certain inputs, essentially, right? And how do you do this? As we're talking about with the dishes, it isn't necessarily having a lot of fancy tools and that type of stuff. It's having a process. So people come to me and say, hey, I built this, multi-agentic framework with multi-turn conversations and LangChain this and Crew AI that over this like infinite RAG we're doing, and it's not working. And I'm like, whoa, what's the goal? And they're like, oh, we've got these documents we want to serve to users, and we just thought to build this thing on top of it. And I was like, well, that doesn't even sound like product specs. So actually getting AI engineers to build out product specs, defining users, personas, doing some scenario analysis. So even before rolling out to users, writing the top 3 scenarios you'd think to use this product to be used in. And then, as I said before, something we toasted over is generating synthetic data in order to test and evaluate your system, building what I call a minimum viable evaluation harness. So a reproducible script that allows you to, if you're using OpenAI and Gemini 2.5 drops, to swap it out immediately and get a sense of how performance changes and iterate on this rapidly. And we can go into detail on any of those things, but it's really this rapid iteration from building to deploying, monitoring, and evaluating, right? And then as you iterate, maybe you do some prompt engineering or change your embeddings or fine-tuning or change your business logic. Then when you're deploying, you add unit tests and continuous integration and versioning. Then when you're evaluating, this is actually a big got you. A lot of engineering-minded people will come to me and say, look, I'm evaluating at all these individual LLM calls. And I'm like, what? You need to evaluate a business metric call as well, essentially, and pair those up. So one example that we actually go through in the course is we build a system that ingests LinkedIn profiles and automates outreach to people that fit certain criteria, right? And the question isn't, does it get the structured output correctly? Does the email drafted look like the email that's the domain expert would write? Of course, all of these things are necessary. The question is, though, do we get better candidates more quickly, right? And so if you can then go and tie these individual technical metrics to business metrics from the start with a minimum viable evaluation harness, you'll come a long way. So it's the building, deploying, monitoring, and evaluating, and having that really tight feedback loop. And also, in a lot of people's defense, people have documents that they think users may find interesting, and they have APIs that they want to give people access to. So it's a whole new world. And I've seen a lot of people deploy things where they don't even have a sense of what they want their product to do until they launch it. And then they start defining metrics. And I'm all for that, right? Have an experimental mindset, be curiosity driven, but you can't just deploy and then leave it and work on V2. These are almost, because they contain, because they let's say, take in so much of the entropy of the real world through data, there is one view of them as being organic. Now, I don't mean in terms of biological, and this is really an analogy, because I don't like the anthropomorphization of all these systems. But there's something that you need to keep an eye on, the health of, and all of these types of things. They're changing constantly, right? So you need to build trust with them at the start. And maybe, so let me just say that, as I said before, a lot of the techniques in you, a lot of the ways of thinking are old. Like if you rolled out a big recommendation system back in the day, at the start, you'd deploy it to, 0.X% of users and keep an eye on it. You'd look at the dashboard all the time. And only when you were sure it was a bit chill would you get your own coffee and not make someone else get it for you, right? And then over weeks, you get more trust with the system and so on. So I think that's how I and a lot of our community think about such things.
And that's so you covered a lot of things here, which are super interesting.
Yeah.
So when you first started, it started off a lot around things like, well, you have to have good specifications and requirements. You have to have acceptance criteria. You didn't say that specifically, but that's kind of what you implied. Test-driven development, user stories. You started to get later into sort of metrics and what is success. I mean, these are just good product management responsibilities, right, that you should apply to these projects. And maybe some of the lesson learned there, or the lesson to learn there, is because of how fast it is to just slap an LLM, just point it at a document and say now we can talk to our policies or something like that. It's like, but what do people actually need to do, which starts to get into jobs to be done and things like that. Like, what is it that they're actually trying to accomplish? What's interesting?
And maybe I can just add a slight bit of color to what you just said. Yeah, it's all the types of principles we've known in product and software engineering for a long time. The challenge now is that if you're using the hottest new agentic tool, you literally at the start can't introspect into your system properly. It's really tough from most frameworks to get out the prompt. You can see the query you provided, but a lot of the time, I mean, Hamel Hussein has a blog post called "Fuck You, Show Me the Prompt," directed towards vendors, among other things. And I'm not cussing on your show. Well, I am, but I'm quoting.
We can't. We don't care.
Cussing's allowed.
And so, like Llama Index, for example, you give it and I love Llama Index. Don't get me wrong, but you have to dig out the prompt. So that's why one of the first things I get people to do is to rewrite their MVP in my case, in vanilla Python and LLM calls, because I work in Python. If you use TypeScript or something like that, totally chill. But as soon as you start writing vanilla Python and LLM calls and then start looking at your traces and looking at failure modes, so much emerges. So that's just a bit of color to the great stuff.
No, I think that's extremely helpful color. And here's the question I have that kind of comes out of all of this, is that like there are certain concepts that kind of are similar when you look at developing a regular product or a traditional engineering product versus an LLM product. For example, this idea of an MVP, right? Like, I think everybody kind of in product engineering understands, like, oh, there's a minimum, viable or valuable product, depending on which one of those you want to use here. When you're building a traditional product, right, it always does too little. Right. And it's like, oh, well, what is the minimum amount of functionality we have to build? And so now you have this minimum platform. And then when things fall outside of it, well, the button doesn't even exist. Like, there's nothing you can do there. Right. So it's like, it's in some ways it's safer. With Gen AI applications, a lot of times the MVP is the opposite. Right. It's like, okay, we've put some constraints on a particular use case, or we've fed it a little bit of context, but then it's just going to grab all of its general knowledge. So it's actually, the MVP is incredibly capable, except it does all the stuff that you don't want, or it's not trustable because it's just making stuff up, hence the hallucinations. Right. So long story short, or coming to the question here, is that probably changes the way we have to approach testing them, right? Like, I guess what are your recommendations as folks are trying to figure out how do I create boundaries without killing all the creativity around these applications?
Yeah, so the first thing is, I think what we see now isn't the best mental model for it. I've found isn't test-driven development. It nearly is. It's what we call evaluation-driven development, which involves a lot of tests, but the core part of the loop isn't using this test or that test. It's using your evaluation framework, right? As opposed to traditional software. Even, remember when I came up in the 90s, right? So when you'd get an update once a year and they'd send you a floppy disk or a CD with the update on it, right? That type of software, you know what the functionality is supposed to be. You can write a comprehensive set of tests and call it a day. And, they're, modulo, I'm not, saying it's easy per se, but now, to your point, with not only, the non-deterministic behavior that, given the same input, these things will give different outputs, maybe do different tool calls if they're allowed to do that, different agentic behavior, the fact that the way users use them is through natural language. You get, arguably, for all intents and purposes, an infinite number of possible inputs as well, right? So how do you even think about testing these things? It's really having the first-class citizen of the loop being the evaluation framework. The other thing worth mentioning, and I've had this conversation with too many software engineers, we almost need a new noun for test and verb for test, because rightly so, for a lot of software engineers, tests should pass 100% of the time. When it comes to data-powered software, if your tests are passing 100% of the time, there's something wrong with your tests and your system, because of the entropic nature of such things. They shouldn't be. Now, stepping back to your question about almost the infinite potential within these systems, as opposed to building an MVP, where you have a few things it can do. That's such an astute point. And to be totally fair, I gotta say, besides flashy demos, the best consistent, reliable software I've seen built with LLMs has LLMs strictly contained in business logic units with very serious guardrails, where they can perhaps do only 3 things. You can imagine a travel assistant that literally is told, these are the 3 things you can do. If anybody asks you for anything else, tell them I'm a travel assistant that can do these exact things. What's worse, of course, is that it will do, you just, because it's an LLM, you put that in the prompt or the system prompt or something like that, right? Of course, you can fine tune later these types of things, but you put it in the prompt, it will still do other stuff, every now and then. So then you want guardrails around it, some sort of, whether it's fuzzy matching or another LLM as a judge or these types of things.
Okay, this is fascinating, because we're thinking about the comment that's stuck in my head right here is, like, in traditional software, testing should pass 100% of the time, but should not. If it is passing 100% of the time with what you're building with LLMs, and there's something wrong here. And so, specifically, what are because you have your evaluation framework. I want to dive into, like, what does this actually look like? Like, there's unit tests, like, this is changing, like, where are we getting our if you're not calling them test cases, and what are they, like, where is this coming from? I know you brought up, like, synthetic data and stuff. Like, how do actually people start setting this up, and what is the process of doing this? Because you actually have, like, QA, right? QA engineers and people doing that. Like, how is this changing when it comes to building applications with LLMs? And one thing I want to add to this is, like, are we eventually going to see LLMs involved in all pieces of software that we're developing? Therefore, it is changing the entire way how we are developing software? Or will we actually have kind of clear boundaries and saying, no, we do software here which is fully deterministic. There's never an element to never deal with non-deterministic stuff. Therefore, traditional test-driven development is going to work here, and or not. Like, are you seeing these? Are we going to have clear boundaries, or is this just going to merge, and then eventually software engineering development is just going to change, because you never know when LLMs are going to be in there, and we're dealing with non-determinism?
Well, I would even ask that. So that's an amazing question. I step back and ask that even pre-LLMs with respect to machine learning. Are we going to see machine learning in all software? And I'd say in heavily regulated environments, maybe you see less. But in all honesty, in finance and health, which are the most regulated, we see a huge amount of machine learning powered software. And in fact, arguably, it's not. It wasn't originally machine learning, but credit scoring, right? One of the most important algorithms and most impactful has always been this weird, like, black box statistical thing, right? Which impacts people's lives at scale. But in terms of actual software, it's a fascinating question. I think we'll probably see a lot, whether it's LLMs or not, or AI more generally. I think most software will be data powered in some way. And actually, because we live in this part of our civilization is this era in it is about personalization as well, right? On top of that, when all models are accessible to everyone, moats come through data. So I think some of the most successful businesses will likely be data powered and personalized. So whether it's LLMs, ML, or statistical inference, I want to see more like Bayesian inference and probabilistic programming stuff in software more generally, in personalization. But I think we will see non-deterministic systems nearly everywhere.
So then what are the patterns, or what are the principles behind kind of doing these evaluations? What are the things that we should be learning regardless of whatever framework or language that's out there? Because those are the principles that should survive the test of time for this new era that we're in.
So let's think about what we want to evaluate and how we want to evaluate it, right? So I really care about cost and latency, aka time and money, are really important to me, as they are to nearly all of us. User business metrics are super important, right? As is accuracy. And I use that term more generally, whether you're doing accuracy or precision or recall or whatever metrics you're interested in, right? So these are all types of things you want to evaluate and track from the get-go. And so let's say you've got a system, an agentic system, as I was mentioning before, where you've got OpenAI, then Gemini 2.5 comes out. You want to be able to switch it out, roll it out internally, or to a user simulator, a synthetic data generator, see how it performs. So you want to get out cost, latency, and then we want to think about performance in terms of how the model and the system performs. But you want a script which will automate this essentially. Now, in terms of thinking about how good the system is, so the first thing is, a lot of people come and say, oh, can I use an LLM as judge immediately? Now, for those who haven't heard of LLM as judge, this is a way of scaling, essentially, evaluation. So let's say I'm generating 1,000 user simulations. I can't then go and say yay or nay, like pass or fail to each of them. So I need to use some system to do that. Getting an LLM to do it is one of several ways. And that's probably one of the most important, modulo, very key details. So first I'll say, if you want structured outputs such as JSON or whatever it is coming out of your system, you can test for these things without using LLM as a judge. If you're looking for particular strings or things that look like certain strings, you can use string matching and fuzzy matching. Now, there are a whole bunch of things you can use along these lines to test what output looks like. And these are, of course, more robust and less expensive than LLM as a judge. But in the end, you will want some system which matches your own human evaluation methodology, but scales it. And this is like what machine learning is, right? It's stuff that humans can do, but it's annoying for us to do at scale. And so we get machine learning to do, or impossible for humans to do at scale. So people say to me, how do I do that without labeling the data myself, Hugo? And I say, get out of here, because the only way to do that is to hand label it. And if you're building a system, you should look at the logs. You should look at the conversations. You should label it. Get in there. Get a spreadsheet or some JSON viewer and look at prompts and responses. Then label them, pass or fail. Then have another column which gives a reason why. Okay. So you can do that 20 times, 50, 100 times. I actually suggest people do 100. I usually say 20 because people balk at 100. Now, what happens then? You start to see different failure modes emerge. Okay, you can say, oh, these hallucinations occur with these questions, but not these. And then suddenly you're starting to classify your errors. Now, heaven forbid, instead of talking about LangChain, I talk about creating a pivot table, right? Whereby you then have a column called failure mode, pivot it to rank order your failures. Now you know what to work on. Now, what else have we got there? We've got a whole bunch of hand-labeled examples we can use as a test set now. And we can, think about encoding this with structured output, string matching, fuzzy matching, or an LLM as a judge. I give an LLM as a judge 50 positive, 50 negative examples, then tell it the goal, and then get it to assess new interactions and give it pass or fail and a reason. And that's the first step towards this reproducible evaluation framework. Now, the next step, which we can go into, but I think it's super interesting, but there are a lot of nitty-gritty details, is then how to, and Eugene Yan has written a lot about this actually, and I'll send you a link to his blog post on it, then aligning your LLM as a judge with you as a human evaluator, okay? Which is a super exciting thing. But once you've done that and have your basic minimal viable or valuable evaluation harness, which is literally a script which implements these structured outputs, string and fuzzy matching, LLM as a judge, you can write it in 100 lines. And actually, I'm teaching a lightning lesson on some of this stuff I'll share a link to a GitHub repository where I have some mock code for building this type of system.
I really appreciate it. And I like how you said like the what and the how. So separate these things, right? The what, time and money, and accuracy. The how, we talked about elements of the judge. Or like this is a great framework of that. Tim, I know you had some couple of things before we go to the lightning round.
Yeah, I think honestly, I think I was starting to ponder some different directions here, but I think actually we started to get to it at the end. I don't know. Before we go to lightning round, Hugo, anything that you think that that we're missing here that we need to make sure that as folks are thinking about building these applications and particularly trying to bring them to production, right, need to be thinking about?
Yeah, this is a bit meta, but two things: talk with as many people as possible. And whether that's emailing or social media, be mindful of social media, of course, because it lies to you. And in particular, I know I'm jumping around a bit now. Social media wants to convince us once again that the world is model focused, and it isn't. It's data focused. We needed to all the data.world, right? What a wonderful antidote to Kaggle. And I don't mean to be so reductive, but Kaggle's incredible. But one of the challenges with Kaggle is a generation, and this isn't Kaggle's fault, but a generation was convinced that tuning hyperparameters was how you build things in production, and not look and feature engineering, but not collecting data and these types of things. So much so that, pre the plague, Andrew Ng came along and was like, we need data-centric modeling competitions. And I think he created one where you hold the model constant and then you change the data. Awesome. Now we're back in the model-centric world, and we're all just obsessed with these shiny things, and they are so shiny. But do not forget that whatever defensible moat you and your people and your business has, it will be around the data, not the model. We all have access to, modular details to the same models. So I think that's important. But do talk with as many people as you can, because there's so much happening in the space. And curate your feeds to get high signal as well. It's difficult on the platform formerly known as Twitter now to curate anything, but besides that, I think that you can get high signal in a lot of ways.
That was a fantastic, honest, no BS kind of just a final thought there for folks. I really appreciate that, because what you just said here is like a whole generation was convinced that tuning patterns, tuning parameters was a focus, and yeah, that's tiring and pisses me off now sometimes.
A whole class of software was developed around hyperparameter tuning and things like that. It was like, man, I know it's still useful in certain cases, but we really got obsessed about it for a minute.
All right, so let me kick it off. So lightning round. First question: are DevOps or data ops fundamentally going to change also because of Gen AI, or are the first principles here the same?
So that's a great question, and I think the first principles will remain the same. And the way I think about, especially ML ops, which is a large part of my background, is because of the new nature of ML powered applications where you have, real world data coming in. You've got a lot of different skill sets, and you have experimentally minded people coming in who want to focus on models and experimentation, but need access to all the data and versioning and orchestration. So that was kind of the stack that emerged. And I think it will remain the same for AI, just different parts will require different solutions and tougher solutions. So I think versioning with AI powered applications, because there's so much natural language data, is like a far more challenging issue than doing the opsy stuff around versioning for XGBoost powered fraud detection, which is tabular data or something like that, right?
Yeah, that's a good question. All right, second lightning round question. So some folks recommend that you should use a different LLM than the one that you're using for your app when you're doing judges. Is that a legit recommendation?
There's no free lunch here. So I would actually say the way to figure that out is probably problem specific, and play with a bunch and see what aligns with you. And if you're not like I did say, don't be so model focused. Having said that, like I'm chatting with Claude in 3 tabs at once and got ChatGPT open in a different browser. Like, it's, and get them to critique each other. There's nothing more fun than getting LLMs in
pitting AI against AI.
AI battle. Yeah.
All right, next one is the best way for engineers to get better evaluation-driven development to, well, of course, take your course and read your material, but is it just like building AI apps and trying to bring them to production, or what other suggestions would you have?
Absolutely. And I think one challenge I would have said about this back in the day is I knew a lot of people who wanted to do it, then they tried it and they didn't enjoy it that much. So if you're a software developer, maybe you don't, there are certain things you don't, there's lots of stuff I don't enjoy and kind of want to do, but when I tried, I'm like, no. Having said that, now the barrier to entry has been lowered so much that you can get a sense of how to build these systems by jumping in, doing it, iterating rapidly, and there's no better time to try to do it on something personal as well. Spin up Olama. So this is a way to run local LLMs on your own laptop. I mean, normal MacBook Pro, consumer grade MacBook Pros have like 4, 8, or 16 GPUs now these days, right? It's insane. You can run stuff locally, get some of your own documentation in it, work with Cursor or whatever to explore your own systems. And doing that with personal stuff, I think, because you've got skin in the game, it will make you build something that's useful for you, and you'll get a sense of the whole life cycle there.
I love that. That's a great idea. All right. Fourth and final lightning round question. You mentioned that some of the best agentic apps have LLMs wrapped in some pretty tight business logic. Do you think that is always going to be the case?
I have an open mind with respect to this, but at the moment, not only because of hallucinations, but because of forgetting as well. Like, I'll try to build an agentic system that, is supposed to have 9 tool calls, and it will only have 4 or 5 90% of the time, right? So we don't only get hallucinations, we get a lot of forgetting. So if we can somehow reduce loads of hallucinations and loads of forgetting, maybe, then we could. I can't see that being possible in the near future, though. And especially with agents, like with the failure rates, like if you try to have like 4 calls in a row, like a chain of 4 LLMs, you'll get failure 60% of the time or something like that. Once again, I would take this back to ML-powered software. And a lot of ML-powered software is contained in very serious business logic. I mean, for example, Netflix well, at least they used to batch all their recommendations, right? So they wouldn't, and that cost them quite a bit, but then in terms of latency, they could serve everything super quickly, and they had verifications around all types of stuff there, right? Similarly, if you think about a product like Google Search, an ML-powered product, like there's a lot of business logic that goes into the development and serving and productionization of that.
This has been for me like a big aha moment. This conversation was like, I've been kind of putting like, oh, LLMs is this new world. We're like, but there's a lot very similar to how we've been doing ML. Like that. I mean, at the end of the day, it's somewhat. I mean, it's probabilistic, right? So, we've been putting that stuff in production. Not only have we putting that stuff in production in people's lives, but it's been powering a lot of the stuff that affects you financially, right? Affects you legally, affects you, right? Your healthcare. So it's like we aren't. This isn't like super brand new territory, right? We're kind of doing some of the stuff. So this is. Thanks for bringing that up, but and kind of you've been illuminating.
Yeah, and that's why I think the skill set is so important. The methods we're now developing for LLMs, there are some differences, but a lot of it is how we've been building ML-powered apps. It's just more difficult now with all the natural language stuff as well. And the other thing is the ability to create a demo super quickly, use synthetic data with LLMs is because to build anything ML-powered, a huge amount of hand labeling had to go into it, or like getting data that was hand labeled by someone else and not really, even knowing what it was, and then productionizing it. So.
This is a really good perspective here. And honestly, I think one of the bigger challenges is not going to be for technical people to wrap their head around what we just mentioned here, right? I think it's going to be for especially the business stakeholders who are very excited about this stuff, who are just like, yeah, throw an LLM at it, right? It's like, no. Like, this is just one part of a much bigger process here. And it doesn't change the fact that, you want predictability. So
exactly.
All right. Takeaway time. Tim, take us away with takeaways.
All right. So we started off with, how can everyone build AI today? And you said, what an amazing time it is to be somebody who's trying to build software right now, right? Start by having conversations with others. I think that was a big theme today, having conversations with folks, right? And start by jumping in with Gen AI to actually, to even learn, right? Like jump into Chat GPT or Claude or whatever you're using and say, hey, here's my current skill level. Here's where I'm trying to get to. Develop a course for me, and it'll actually create something just for you and meet you exactly where you are. And this is some of the, personally, I'm very excited about some of the educational implications of Gen AI. And I know we're just starting to tap into that. Now, everyone in your organization really needs to go into exploration mode, right? This is a time for being open-minded and trying things out. And we've shifted a paradigm here where essentially we're communicating with computers in natural language. And we jokingly, but semi-seriously mentioned vibe coding, and don't necessarily poo-poo on it, because no one's saying that you're going to try to vibe code your way into production, and certainly you shouldn't do that. But wow, how fast you can get to a straw man. But you do need to know the basics, right? You need to know Python. You need to know command line. You need to understand systems if you're going to be effective with these things. But then I asked you, hey, do we, can these things do everything that you want to be able to do? And you said, use the tools you have. Would you ride a bike if you wanted to travel 1,000 miles? No, you would drive a car. So, use the tools that you have available to you, which I think is exciting. Bringing things to production in the Gen AI era. So first of all, you're like, what does production mean? Like, let's get clear on what do we mean by production. And really, it's about starting small and iterating, right? So, you start building an app and you start iterating. You say, okay, maybe I need to add load balancing. Maybe I need to add vertical scaling, horizontal scaling. Maybe I need to add versioning, right? So going into production is really more of a process than it is a particular inflection point. And you mentioned this idea of proof of concept purgatory. And I think this is a very interesting concept. And I know it goes into some really great writing that you've put out there. So folks should check out some of Hugo's postings on O'Reilly and LinkedIn and things like that. With Gen AI applications, it actually starts with the flashy demo, and then you see hallucinations and things like that. And then you're like, oh, how do I monitor this? And oh, how do I make it use my enterprise definition for something? And then it actually has the maximum hype at the beginning, and then it kind of trails off from there. Whereas traditional software is actually the opposite. It starts with kind of like, oh, I've got nothing. This is lame. And then you build one button and one page, and then it iterates and gets more valuable over time. So that's going to require us to approach it differently. There's commonality, such as product specs and user stories and things like generating synthetic data and things like that. So this build, monitor, evaluate kind of flow is similar from traditional and AI oriented development, but there's a lot of differences too. And with that, Juan, I'll pass it over to you. What are your big takeaways?
Yeah, one thing. So you also said is like, if you're one of the things that the issues having with like building with frameworks because they're hiding their prompts. That was interesting, right? Like, you should actually consider building with vanilla Python and the prompts, so that a lot of these things emerge and which you don't realize it gets hidden about these frameworks. That was an interesting point. Another one, the best way to build these apps is not just exactly test-driven development. It's what you call evaluation-driven development. In traditional software testing, passes 100% of the time. But if you're building things with LLMs, if it passes 100% of the time, there's something's wrong with that, right? So, and then how much, we had this conversation about how much software development is changing because of LLMs. And I like what you brought up is like, look, we've been doing machine learning, which is already some probabilistic ways, and that has been in so many regulated industries. I mean, it impacts already in so many different ways. Like so a lot of those principles are already there. Now, think about what we want to evaluate and how. The what, is it time? Is it money? Is it accuracy? And the how, which is we need to test, is how does that output look like given some inputs? You can use LM as a judge. We can align with other human evaluators. Yes, use string fuzzy matching type of stuff. And when people kind of complain about, hey, what about manual labeling? I don't want to go do that. These are things you got to go do. You got to look at your logs, look at your prompts, find correlations between the prompts and the errors that you're having and so forth. And just to kind of wrap up, you said talk to as many people as possible. And be careful with everything you're seeing on social media, right? Kind of fix your feed there so you're kind of balance that out. The world is not model focused, it's data focused. And there's been a whole generation which was convinced that all you have to do is tune in parameters. And that really is not the case. And I think that's one of the big, I love that closing thought. And with that, Hugo, how did we do? Anything we missed?
No, it was wonderful to hear all my thoughts reflected. I really appreciate that. And I've loved when I've heard you do it on the podcast as well. Really nice touch.
Well, as we always say, is like, this is all you. So thank you for sharing everything.
And the nuggets are amazing here. Thank you for sharing your expertise.
So to wrap up, what's your advice about data, life, whatever you want? Second, who should we invite next? And third, what resources do you follow?
My advice is for people wanting to do this type of thing, get in there and build, but do it mindfully. I mean, maybe have a YOLO session if you want, but know the type of debt that you take on when you build with AI-powered systems. And just to be clear, I do think we've all been vibe coding a bit for years anyway. We just haven't been able to do it AI-powered. Like, who hasn't gone to Stack Overflow and copy and pasted code they don't understand, right? That's vibe coding is essentially that at scale. So let's not all act like there are a bunch of vibe coders around and like we're not all part of what people may consider a problem. But get out there and build, have some YOLO sessions, but do it mindfully. Also, build with friends and see what's up. In terms of who you should invite next, I got to tell you, I've been reading once again a lot of Sebastian Rajka's work and content, and so he was at Grid until recently. I think he may not be there anymore, but he has a book called Building LLMs from Scratch, and he's just an absolute beast. And he's contributed to Scikit-learn, Pandas over the years, Matplot. Like, he's done so much in the space. And I had him on one of my podcasts once, and he did a demo of how anyone can train GPT-2, which is an archaic model now, but you can just train that from scratch. So having him on would be super cool. Oh, and that's shameless self-promotion. I do have 2 podcasts as well called Vanishing Gradients, where I have conversations like this, and then High Signal, where I speak with a lot of, I suppose, like some of the best people I consider the best in the space. And I'd encourage everyone to check out my most recent conversation, which is with Tim O'Reilly, about an essay he wrote called The End of Programming as We Know It. And he really talks about what will be unlocked now with natural language interfaces. So definitely check that out. So a bit of shameless self-promotion.
Oh, no worries at all. Vanishing Gradients and High Signal.
Exactly.
And
any other resources you follow you want to call people out to?
Yeah, so of course, I look at Y Combinator, Hacker News, Medium, a bunch of stuff on Substack. Our mutual friend Joe Reese. I do want to say probably one of the best blogs and one I learned most about the space is Simon Willison, he's one of the few people who's like on the Python side. He's a co-creator of Django back in the day, but he's also big on the data and LLM side. I see on his blog like a post about Gemini 2.5, his experiments with it before I've even seen it's been released, right? So him, I mentioned Sebastian Rajka, Chip Huen, Shreya Shankar, who's at Berkeley, and I'll share some of these people in the show notes. Jeremy Howard is someone I consistently learn a lot from also. So yeah, those are a few names.
That's awesome. Love it.
Well, this was fantastic because I love how we're very a data focused podcast, and you brought up like the not only the LLM part, which you've talked about, but also the software engineering part. So I really appreciate giving us different perspectives. Hugo, thank you so much. Truly appreciate it, and looking forward to meeting again soon somewhere in the world.
Likewise. So thanks once again, Juan, and thanks, Tim. It was